Hi, my name is Sophia and I'm going to be one of your smart word guides.
So here's a problem that someone sent in. They asked, if you know that the area of a square is 50 and it's sitting inside of the circle like this, what's the area of the circle? Okay? So the actual problem set up was something like square of area 50 is inscribed within a circle. What's the area of the circle? Okay, so sorry about the picture, but I don't want to waste too much time on that, so this will have to do. Okay? So if we're looking at this guy, so I know that the area of the square is 50. I know that the area of the circle that we want is something like pi r squared. Okay, so even before we compute, you know the game plan. The game plan is once we get this radius, we are done. We just plug and chug, right? So somehow I want to link this square, use information about that square to get the radius of this circle. Do you guys agree? Okay, so before we do that though, let's do a little work on the square. So you know the area of a square is the length of its side squared. So that would be 50 in this case, and let's call the length of a side s. So it would be s squared. So in this case, the length of the side would be square root of 50. Okay, so that tells me this right here is root 50. Okay, that's nice, but it's not getting me where I want. I want that radius, right? Maybe easier to visualize in this picture, the diameter. Let's go for that. Okay, so again, this would be root 50. The diameter is all the way across here. There's no pretty line up there. Okay, so I keep trying to find some relationship, get to here, then we notice something pretty happens, right? So we notice that this guy here, not only is he the diameter of the circle, he's also the diagonal of this square. So maybe I can use that relationship. Do you guys agree? And a lot of different tricks, but an easy way to see this is, you look at this guy, he's a square, so this is a 90-degree angle. You see that we have a triangle over here, right? You know this side is root 50. You also know that this side is root 50, because it's a square, right? And any way you want to work it, since these sides are the same, this is an isosceles right triangle. In fact, it's a 90, 45, 45. So there's a shortcut for that. Or you can do Pythagorean. So let's do Pythagorean for a second. So you know 50 squared plus 50 squared equals the length of this side squared, right? But then square root of 50 squared plus square root of 50 squared, that's just 50 plus 50, right? So that's the length of this guy, d squared. So that's 100 is equal to b squared. And then it's really pretty, because then 10 is equal to d. Okay. Oops. Okay, something like that. Again, a lot of shortcuts here. You could have used the whole, like, this guy is root 2 times the length of this side, then you would have gotten root of 100, which is also 10. Any shortcuts are fine. But anyway, either way we get the diameter is 10. You know you don't really want the diameter, you want the radius, but that's really easy, because the radius is half the diameter, so the radius is 5. Okay, now we're home free. So let's finish this. So you know the area of a circle is pi r squared. So you know the area of the circle is supposed to be pi r squared. I'll put a circle here. Okay, so the area of the circle is pi times, I guess in this case, 5. 5 squared, right? So I guess it's 25 pi. Okay, so the computation isn't that bad, but it's just linking these ideas, right? You know they gave you the area of the square for a reason. You know that can get you the side, right? We try to find a matchup between the side and the diameter of the circle because we knew in the end we wanted the radius here. So big ideas were use information about this to get the radius. Sometimes it's easy to visualize the diameter, so we tried that. But the diameter didn't line up well with this side. Do you guys agree? So we kept playing with it to find what did the diameter line up with. It didn't line up with this side, but it did line up with this diagonal. Do you guys agree? Once we had that diagonal and that setup, then we can use information about the sides to solve for the diagonal. Once we had that, everything was done. Okay, so not too bad, right?
See you next time. Hi, my name is Stephanie. If you have any questions, just email me. Bye.